We're on lesson 6 of this module, topic 1. And module 3, topic 1, we're talking about partitioning segments into given ratios. There's a technique we'll use where measuring or creating the segment will be done with like a compass. We're going to actually do some compass work instead of just straight up tracing paper. However, go ahead and get your highlighters out, get your pens and pencils ready to go. Have a calculator, maybe your phone calculator or Desmos or one of the other school calculators. But let's get into this one. I'm going to begin by highlighting something called a directed line segment. It's like a vector from, Despicable Me, where something has both direction and magnitude. Actually, yeah, it's a vector. It's just called a directed line segment right now because we want to say it like stops that magnitude conversation. Use the distance formula to partition a directed line segment into a given ratio, and then determine the points where the segment is divided into that ratio. We're also going to be using some geometric reasoning and the concept of proportionality to partition that directed line segment. Let's use that information, highlight what I've highlighted, and in fact, maybe like you should pause the video right here and write down everything that I've got written down for the review. I'm going to talk us through number 1 after you come back from pausing it and writing it. Then I'm going to do number 3, and then we'll finish number 2. It is a little bit out of order of the 1, 2, 3 sequence, but I feel like it works best that way for us to leave number 2, the second one, for last. So pause, and then unpause, and I'll go back into explaining it. I'm assuming you paused it, so let's go. In the first question, the distance formula here of x sub 2 minus x sub 1 is a quantity that's squared, and we're going to increase that, so plus sign, by the quantity y sub 2 minus y sub 1 squared. All of that entire expression will be square rooted. That's going to be the formula that we're going to use. Hold up a second. All good. Got a student ready to go. So in the first question, we have the x1 and y1. I went ahead and labeled on all of these, and you probably did too if you paused and wrote it, because this is literally just the first one, and therefore the x coordinate gets an x with a 1. The second coordinate gets a y with a 1, and this is how we know in the formula x sub 2 minus x sub 1, we know what number should replace x sub 1. It's 9. Which is why in the formula here I have 9 going first. And therefore all of these 4 numbers find their home in the formula in this pattern. X sub 2 is 16, x sub 1 is 9, there's a minus, they're in parentheses, and they're squared. Y sub 2 is 2, y sub 1 is 4. They go in their own respective locations in the parentheses, and they're squared, and then all of that is square rooted. So I hope you can do 16 minus 9. If not, oh my God, calculator, but please do 16 minus 9. Know how to do that math. That's 7. And then 2 minus 4 is negative 2. So we're going to square both of those. One rule of thumb, a thing to remember, is that we should put parentheses around our answers if they're negative. That way the square of a negative number is going to become positive, and that's why you see a plus 4 here. Sometimes when you do this calculation in your calculator, you don't put the parentheses. I've seen students do this over and over and over, and then therefore they get a 2 squared, make it negative, and they think the answer is negative 4, and that's not the case. A negative 2 squared is positive. 49 plus 4 is 53, and therefore the square root of 53 is approximately 7.2801. In question 3, which is better than question 2 right now, is I put all of my labeling down. So I have x1, y1, x2, y2, and I put them into the formula in the same arrangement. X sub 2 minus x sub 1, y sub 2 minus y sub 1. There's a lot of 8s being thrown around, but that's okay because what we're going to notice is 20 minus 8 is squared, and 8 minus 8, so that minus that makes the y2 minus y1 part of the formula. That's also going to be subtracted and squared. When we're done, we'll have 12 squared plus 0 squared. Now, I could just jump right to the math and say, look at these things that cancel, but maybe I'm going to say, maybe you're just trusting your calculator. And if you dare go, hey Siri, what's 0 squared?
It's 0.
It should literally like start laughing at you because 0 squared is 0, and you're going to add that to 12 squared. But I know that 12 squared is 144, and we're square rooting. And maybe you did a different path. Maybe you photomathed it or something like that, and you got a different path direction from photomath. But at the end of your math versus mine, we both get 12. What I'm going to suggest you do is a second pause of the video, and that is that you do question 2 from these 2 examples. You do question 2. I'll, of course, do it in the video, but you should pause it and skip all the way to the end of the video just to see if your answer matched mine. And I'm not really going to do much more like talking out loud explaining. I'm just going to like let the math flow. Therefore, pause the video, work out question 2, and check if your solution matches mine. Okay? Here we go. It's going to be a tricky part right there. Okay, 2 squared plus 9 squared equals 4 plus 36, so that's 40. 40 is 4 times 10, and the 4 can be square rooted, so it's 2 square root 10. Hey Siri, what's 2 times the square root of 10? Hey Siri, what's 2 times the square root of 10?
2 times square root of 10 is approximately 6.3245.
I'll leave you with this quote I thought today. We've got a quiz for my regular session on this day of the calendar when I'm giving this thing. I have a quiz today, and it bothers me so many times when students say, I'm going to fail this. If you say that, you're right. It's called a self-fulfilling prophecy. What are you going to do about it ahead of time? Why didn't you do that already? I'd like to know. Thanks for watching this video. Page 520 is coming up next. I'll see you in the next episode.